There we go. Once you're done with high school, life is going to be better. Trust me, I was so happy after I'm done high school because then you get to pursue what you want. Okay? Some of you are going to miss it, I know, but it's going to be better, trust me. We have explored how much each measurement has an uncertainty or margin of error. This isn't right here. That, not how. Okay? We have explored that each measurement has an uncertainty or margin of error. This is due to the limitation of the measuring device, also known as the precision. But what happens when you combine measurements? Okay? When you combine things. What about when you keep removing an amount from a larger batch? Okay? What happens then? Like, what happens to those? There's like multiple uncertainties that meet. And so we need to account for that. And so this is basically, in words, what we're going to do today. The total or combined uncertainty is the sum, the addition, of all the uncertainties that are present. Okay? This is due to the fact that each time something is measured and added to a total, the uncertainties also increase. The margin of error increases because something is measured repeatedly. Okay? Margin of error increases because something is measured repeatedly. So my best example of this is airplanes. Like I made a trip to South America, but what do they do with your luggage every time? I don't know if you've flown before, but your big luggage needs to be under a certain amount of, like a weight, there's a weight limit. So every passenger puts their luggage on the scale and they keep adding the total weight that's going into the plane. So every single time they weigh, there's a bit of an uncertainty that keeps piling up. So technically, when they weigh everything, they could be off, right? The total weight of all the luggage in that airplane could be more or less than what shows on the computer. And so that's why you keep adding the uncertainties. It may seem insignificant in most sectors, but it is very important to consider in some industries. I'm going to repeat this again, so I'll just leave it, the airplane example. What about a gas station? A gas station needs to be aware that the amount of fuel remaining in their holding tanks may be higher or lower than expected. Why is that? Because every time someone draws fuel to fill up their gas tank, right, the pump always measures, like you fill up, click, right, you're full. Next car comes, full, right? And so that the pump is keeping tally of how much liters are being pumped, but there's always going to be some uncertainty every single time. You're going to be off by a little bit every single time, and that keeps piling up. And so they have to be aware of that and make up for that, okay? Because the pump is basically a measuring device. It has a way to measure how many liters are going out of that big tank underneath the gas station. Okay? So that's the idea. So let's put this into practice. 3 pieces of fabric are being sewn together. Determine the precision and uncertainty for each piece. B, calculate the total length and the combined uncertainty. Then determine the shortest and longest possible combined length, min and max. So there's going to be a little overlap of what we've been doing so far. So you've got your 3 pieces, right? If you want to put it this way, there's this one piece sewn together with another piece, and you sew that together with another piece. So that's the idea, right? Sew together, stitch it up like that, and they each have their own lengths, okay? So what you do, what I would recommend you do, this is just a suggestion, okay, how I have it set up here. You're listening, right? I will say, okay, this piece right now has a precision of 0.1 centimeter, right? You will realize that the precision is going to be, we're not going to use it later on, but we needed to come up with our uncertainty. So my uncertainty based on this, divide this in half, you get 0.05 of a centimeter. That is important to us. So we're kind of doing that for the first piece of fabric. Piece number 2. What do you think the precision is for the second piece? Exactly the same. Do you notice that? Just 1 decimal. So copy paste for now. There you go. They won't always be like that, so don't be thinking, oh, that's easy. Next, what's the precision of this one? It's the same, right? They all have 1 decimal, so because I want you to focus more on this next piece, I made them all have the same precision and uncertainty, so we're not getting stuck on that piece. So A is taken care of, okay? A is taken care of. We've determined the precision and the uncertainty for each piece. Now it says calculate the total length and the combined uncertainty. I'm going to use 2 different colors for those 2 measurements, okay? So the total length and the combined uncertainty. And the word combined uncertainty, right, if you think about it, you're combining a bunch of uncertainties from the different pieces of fabric. So for B, I will just do this. This is for B. I will just go piece 1 plus piece 2 plus piece number 3. So I'm just adding them up. And then I get my long piece together. So let's do some mental math here. 4 and 3 is 7, plus 1 is 8 centimeters, right? 0.8 that is. And then 5 and 0 and 0 is just 5. 6 and 3 is 9. So we've got 95.8 centimeters. That's my total length. That's the total length of the pieces, right? And I go all the way, you skip this, skip, right? And then this is the one you're going to add up. Okay, so they're all the same. So you can do one of 2 things. Times it by 3, or if you want to add it up 3 times, that's up to you. I'm going to multiply 0.05 by 3, so you get plus or minus 0.15 centimeters. And that is our combined uncertainty right now. So we've got our total length and our combined uncertainty. Quite often they want you to state it. So total length would be 95.8 centimeters plus or minus a combined uncertainty. You've combined all their lengths. You're also combining all the uncertainties. So this is what the measurement should be. So it's same as before, except for now we have a bunch of uncertainties all piled up together. So this is B. We've done B here. There it is one more time. Total length and the combined uncertainty one more time. And some of you will deviate from my model here. You'll do your own thing. You go for it. I don't really care how you do it. You just have to be careful. Especially if they have different precisions and different right? Different precisions will result in different uncertainties. So you could have 3 different uncertainties here, all different. So you just have to add them then, right? You can't do the multiplication piece. C. So we've done B. C, determine the shortest and longest possible combined length, the min and the max. Which one do you want to do first? It doesn't matter. If I go max, I just have to go 95.8 plus, right, the highest value would be adding the uncertainty. You come up with the answer there. Your minimum is 95.8 minus 0.15. you get 95.95 centimeters. I know that we would never do this in real life, right? Not, especially not if it's fabric that we're sewing together. 95.65. But it's just to emphasize the point. Longest, shortest possible combined length. And the reason, right? Like if this is off by a little bit, either on the long or short side, you combine that to another piece that could be off on the long or the short side to another piece. So we keep adding uncertainties. By the way, you can put a bracket here, is always add uncertainties. Always add uncertainties. That is, it doesn't matter. Sometimes we will have to subtract our measurements, because let's say if we're drawing from a tank or if we're cutting off, but you will always add uncertainties. That will never change. So this is the, I would say this piece right here, if you could have this on your study sheet, in a very short, compressed kind of way. But this should be on your study sheet. I'm not going to make your study sheet. I don't usually tell you exactly what's on there, but I'm basically saying, hey, if you want to narrow today's concept down, it's found right in here. Okay, so if you can make that, if you can compress it, so on your study sheet, maybe go and say, precision measurement, page 25, it's combined uncertainty. Right? So the top of this page has the title. Maybe I'll just write it down here. Combined uncertainty. I just want to warn you as well. Sometimes they will only ask for the combined uncertainty. Sometimes all they ask for is this in particular. So can you still do this breakdown? Absolutely. But just make sure that you circle like this is what, if all they want is a combined uncertainty is this. If they want the total length and the uncertainty, then obviously you state it like that. So you just have to read carefully. Just understand what's happening here, what's what, right? So let's do another one. On page 26, this is a subtracting example. Let's keep going. And then I'll let you do a little bit of work if that time will allow. Okay. Moses has a bucket of water with 20.5 liters in it. He needs to draw some water for some plants using a smaller jug, which can hold 1.2 liters. If Junior draws 3 jugs from the bucket, determine how much water will be left in the bucket, including uncertainty. I would say here, there's a combined uncertainty here. There's a combined uncertainty because you're mixing two different, like in this case, buckets or two different measuring devices. You're mixing them up, then you know this is a combination here. So let's do A here. The way I'm going to set this up is I'm going to say my bucket has 2.5 liters. And I'm gonna draw 3 small jugs out of it. So I'm gonna go minus 1.2 liters, minus 1.2 liters, minus 1.2 liters. I know some of you are not gonna bother with the minus. You're just gonna go times 3 and then subtract that. But it doesn't matter. Everybody's gonna arrive to the same conclusion. So this is what's really happening here. Normally this would be it, but we're in the precision measurement unit, so we're going to go precision is 0.1 liter. So my uncertainty is 0.05 of a liter. Could we agree that all of these precisions are going to be the same for every single one? I think you would all agree that that's the case. So let's just fast forward this part and just go 0.1 for all of them, and 0.05 is the uncertainty for every single, especially because the jug is the same, right? The jug is the same, so we expected the precision uncertainty to be the same. The bucket could have had a different precision and therefore a different uncertainty. But in this case, they're all the same. So let's go ahead and subtract. I hope it makes sense that we're subtracting because we're drawing water out. Okay? So you do the math. Minus 1.2 minus 1.2 minus 1.2. So you're down to 16.9 liters. I skipped this part. I used to not write skip. Some students would add the precision together, and that's not, we don't want that ever, okay? Don't do it. But then we go over here, we have a combined uncertainty. So I'm just gonna go 0.05 times 4, because all of these, right, are the same. So that's 0.2 liters. All right. How much is left in the bucket, including the uncertainty? So left in bucket would be 16.9 liters plus or minus 0.2 liters. That's what they're asking for there. This is still a combined uncertainty. I used green before, so this is basically the most common part, is actually the province asking, like, what would be the combined uncertainty. And so if you had drawn 17 jugs, it'd probably be faster to go 17 times 1.2, 17 times the uncertainty, right? And then you're much faster. But again, add, okay? Add here, but we subtract the actual amounts. So that's the thing here, is always add the uncertainties. B, the maximum minimum amount left. So max would be 16.9 plus 0.2. Can you see that? Yeah, it's a little ugly there. I'll redo it. $16.9 plus 0.2. That'd be 17.1 liters. And then the lowest would be 16.9 minus 0.2, and that would be 16.7 liters. Just make sure you label which one is max and which one is min if you want full marks. C. If junior needs 17.5 liters to water a tree yet, so the bucket is standing there, and you realize I need this much for the tree, will you have enough? And the answer is no, okay? Even if you consider our combined uncertainty, the most you can have in that bucket is 17.1. No, since the most that is left in the bucket is 17.1 liters. I'm gonna post everything from page 26 to 31. I would say you should do at least page 26 and all of 27. 26 only has one question. I will post the key, and tomorrow we're gonna shift gears a little bit, second half, right? We're going to talk tolerance, okay? You've got 10 minutes, all right? Use it.